the Tech Hour started running things along the basis of number one is beginners, number two is accessible documents, number three is conversions, and number four is durable documents. And we're sort of doing durable documents. So what I'm saying here won't by itself provide any help, but it might make things easier to distribute afterwards. So it's a bit like having decent roads and railways. They won't grow any grain, produce any milk or anything, but they'll allow you to get produce to market and into the towns.
I like the way that you describe that.
Thank
Go
you.
ahead, Nelson. I'm sorry.
Yeah. To address your question, Steve, about the capabilities of immediate feedback by changing the input file and seeing the revised output. The tech book is not supposed to be typeset, but what we've done locally is we make a private temporary copy that we can typeset in, and so we can benchmark in a variety of systems. And the fastest systems now typeset that entire book. Now that book, when it was published, has artwork at the start of every chapter by doing Bibby, and that is not available in the tech book manuscript, but otherwise everything else is. Now it's unusual that it's a very complicated input file, but it's also unusual in that it doesn't use much in the way of packages. Don has a book macros package that he loads up at the beginning, and basically at that point, tech can run full tilt through the entire book and produce the book. And our fastest machines do that in about 1,500 pages a second. In other words,
What?
Yeah.
Say it again.
1,500 pages a second.
Mhm.
So it's a millisecond per page. It's potentially very fast. Now, if we look at other documents that we're working with, the problem is that maybe I should have said per minute. I'll have to go back and check my benchmarks. Nevertheless, it's a tiny fraction of a second per page. The issue is with modern documents, many of them have large included graphics files for images. And also in the LaTeX world, they tend to have lots and lots of other files that get loaded. Remember, tech, the tech book itself uses the standard tech fonts, which are essentially already preloaded into the tech engine. But as soon as you switch to another font family, and especially in the Unicode world, those fonts tend to be big. They can be megabytes per font. And so things slow down quite dramatically. And typesetting probably is now measured in a few pages per second. So depending on the complexity of the document and how many external resources it needs, immediate feedback can be possible or may not be possible. Jim Carlson, who's joined us on the Tech Office Hour a number of times this year, has been working on a system that uses a subset of LaTeX as input, but it's a completely standalone system that doesn't require other packages. And Jim has demonstrated that he can do live editing, and there's instant display of a typeset equation as he's typing it.
Wow.
And this works great for student exercises and simple documents. It doesn't work for a complicated document that needs all kinds of figures and special macro packages and so on. So he's trying to address, as a former college professor, he's trying to address the needs of how do we get quick turnaround in typesetting for students, typesetting exercises for homework and so on. Because if they see instant feedback when they've typed an incorrect math sequence, they can correct it fairly quickly and they learn as they go.
Wow.
So that's one possibility for the future and could be a useful thing on some platforms for some kinds of documents.
Thank you. That's very interesting.
Also, there are now multiple tech engines. There's the original tech engine, which Don wrote. Then there is PDF Tech, which Han Taitan wrote for his PhD in in the Czech Republic in the 90s. And then there is LuaTeX, which Hans Hagen and Taco Hookwater have been developing in the Netherlands. And then there's XETEX, XETEX, developed by Jonathan Q at the Sumner Institute of Linguistics in London, England. And the key feature of PDFTeX, LuaTeX, and XETEX is that they can handle native Unicode fonts. But as I mentioned, those fonts are large and they're complicated. They potentially can host of the order of 100,000 characters. And if you're using many different fonts in the document, that means perhaps tens of megabytes of font information. So when I've done typesetting benchmarks on conventional documents, I find that those three systems run 3 to 5 times slower than TeX would producing a DVI file. So that also is somewhat of an impediment. On the other hand, the ability of them to do multilingual typesetting. I have document examples where I typeset 6 or 7 different languages on a single page, some of which are left to right and some of which are right to left.
Wow.
And it works perfectly fine in LuaTeX and XETEX.
Do all of the other three bypass the DVI file?
They all can produce a DVI file if you choose to. But for example, in TeXLive, the startup file that PDFTeX reads says, please produce PDF by default unless someone inputs a document that says turn off that feature. They do that so that they can continue to produce documents that conform to TeX and pass the trip test. And so they're legitimate TeX engines.
I've got a couple of things to add to that. The first is that if all you want to do is instant preview the paragraph, the time per paragraph might not be relevant. What is relevant is the startup time. And reducing that startup time is something you can do by running TeX as a daemon, but LaTeX doesn't support that sort of operation, if you like. It's sort of inconsistent in its assumptions. So a slow process that eliminates the startup time will always win for the instant preview. Now, the second thing is that if you're previewing in a browser and you're using DVI, then you only have references to the images. And if the images don't change, the browser doesn't have to, so to speak, do anything. It just has to notice that the text has changed. So the problems of copying images from here to here to here, even though nothing has changed, is solved if you can use DVI. And my general basis, my general feeling about all of this is that before we're ready for it, if we're not careful, TeX that runs in the browser will become possible. And when I say before we're ready for it, if it's possible for TeX to run in the browser, it's possible for other systems to run in the browser. And if they get there first, we lose the advantage we should have. I'll stop at that point.
Yeah. I just checked my other workstation and looked up the benchmark file. It is indeed pages per second, so a millisecond per page.
Wow.
Much any modern desktop computer. And Jonathan's point about the startup time is definitely significant because that's where the loading of the format files and the style files and some of the fonts happens. And Jonathan's solution a number of years ago was to have TeX as a daemon running constantly with all of that stuff preloaded. And then you could fire off input to that engine and get back instantly typeset output. Because TeX is extraordinarily efficient at its typesetting job. It doesn't take quadratic time proportional to the length of the input or anything like that. It's really a remarkable piece of software and absolutely rock solid.
I will second that because when I started using TeX, it took a second a page. And that was on a 286 machine running at 10 megahertz.
Wow.
And if you start up TeX, it says this is TeX version 3.141592665, blah, blah, blah. If you count the digits in the fraction, that's the number of bug fixes done as applied since 1992. So it's the order of 8 bug fixes in close to 30 years.
I'll follow on that, which is, in a sense, Don has solved the problem of across space, across time, across platforms, as long as the inputs are identical. The difficulty we have, I think, in the tech, one of the big difficulties we have in taking advantage of Don's hard work is ensuring that the inputs are identical. And Git is by far the best tool available today for ensuring inputs are identical. And so you can merge the tech, if the tech inputs, except for the ones coming from the author perhaps, are coming from Git, we've got a very, very good chance of ensuring that the inputs are identical, and therefore by Don Knuth's hard work, the outputs are identical. We
by input be the style files, the fonts.
That's right.
Everything except what the author writes.
Yeah, everything except what the author writes should be under version control, and the secure hashes of those things should be known, so that every time you want to reproduce the document, you can say, aha, this is exactly the inputs that we used. And one of the big problems we have is having a faithful and comprehensive list of the inputs that were actually used. The only way to get it at the moment, despite a file name recorder existing in the command line, it doesn't record everything, unfortunately, is to use system tools to track the inputs. But that's to realize Knuth's wish that tech will give the same results 100 years in the future, we have to fulfill that same goal of preserving the inputs that we need for 100 years and be sure that we know what they are.
Yeah. 2 comments relative to that. One is that Jonathan has talked before about an approach taken in JavaScript of compiling to a pseudo assembly language that's interpreted within the browser. And if someone were able to get the TeX executable to be compiled into that form, it would be runnable in a browser. The second one is that remember that the whole reason that Emacs and LaTeX and TeX have this notion of precompiled files that are commonly used that are then dumped into a format file. The dumping of that format file typically takes a few seconds on a modern system for the various TeX engines and LaTeX and AMS LaTeX and so on. And what one could certainly relatively easily do is to recognize that most documents, once the first cut has been made, the author has settled on the packages that are needed and the fonts that are needed. And so that would be a very good time to dump a new document specific format file. It's not large, it would be, I suspect, just a few megabytes. Subsequent runs then could ask TeX to load that format file instead of the standard format file. And that would then eliminate the subsequent reading of a whole lot of other files and make the startup time a lot shorter. And that would be beneficial both on the current platform where people are running it locally, as well as in a web environment where the browser has done this. So it will take some work, but I think these are problems that can be tackled and solved, and TeX could become an instantaneous typesetting engine.
Yeah, a lot could be done to improve the user experience and provide instant preview. And if we combine all the technologies, I mean, one of the big difficulties of using TeX in the browser is that all the people that are trying to use real TeX in the browser have to download and install a large part of TeX Live. And if we could cut that down and just say, this is what the document needs, it becomes a much more attractive procedure. And the barrier to entry is enormously different. That's the great attraction of Overleaf, is all you need is a web browser and off you go. But that's relying on an internet connection over to a proprietary service. And there's a lock-in there. Whereas if all you need to do is supply the right JavaScript files, and you get an experience the same as Overleaf, that's a big opening up of the whole thing. And it allows tech to be part. You see, often people don't want to do just one thing on a website. They need to do this and that and the other. I know that you're not going to typeset documents in the middle of your grocery shopping, but when you're submitting an article, an abstract to a conference, you might want to typeset the mathematics in it. And so turning tech into a component that will fit in to a corner of a website. And that's really what MathJax does. I think MathJax is really part of the future in all of this. And it answers the question that Steve has about checking the LaTeX has been properly done. And actually, I rather think that the definition of is the LaTeX properly done in practice amounts to, does the LaTeX work properly with MathJax? If it won't work with MathJax, it won't display on a web page. And if it won't display on a web page, it's not screen readable. So you're not losing anything. In fact, you're gaining something by saying the mathematics in the documents you scan should be checked using MathJax. And MathJax as a rendering engine isn't something, as far as I know, that Overleaf supports. And in some sense, it's a threat to their business model.
Oh my
Those are all
gosh.
very nice guys.
Interesting. Thank you. I'm glad you're recording this. I'm going to listen to the whole session again.
Oh my. Well, it's 7:30. I had a longish day. Perhaps we should say goodbye.